This gate has one flaw, and in this video, I'll fix the last remaining flaw of this gate. A marble drop can be broken down in 3 different sections. Attack time is this. Attack. What we're doing right now, we're just holding is here, hold time, and then release time. So release time in this configuration is always constant and always works perfect. We know that an ideal hold time is around 500 milliseconds. But what about the attack time? So the attack time is the speed with which I'm doing this movement. So if I do it fast, we're golden. No problem. But what happens if we do it slow? Let's try. That's a critical failure of the gate. Opening the gate slowly. This marble is not supposed to be dropped that way. It's supposed to be captured by this arm, like that. In the original Marble Machine video, there was a passage where I started the machine from 0 and played slowly and increased the tempo after some time. In order to be able to do that, this gate needs to be able to handle infinitely slow attack time. And to fix that, I made a new gate. In this gate, this part is rotating faster than the other part, closing the door for the marble earlier. It uses a cool slot function here, and I'm really proud over this design. Unfortunately, it takes more parts, but I'm really happy to try it out, and it doesn't work well. It actually locks up in this cool slot function. So when the marble pushes down, the slot creates a perfect lock over here and the gate can't be opened. So I made a new gate. So in this version, we're back to fewer parts, a much less complicated design, and it actually works great. It catches the marble even if I go slow. If it catches it slower, it just raises it up like this. But while working on this, I saw a lot of room for small tweak improvements, so I made yet another gate. This one might be the one. So the previous gate couldn't handle a really slow attack time. Let's see what happens on this one. I'm gonna exaggerate the world's slowest attack time. I'm creeping. Slow, slow, slow. Gate is closing. No marbles has moved so far. Boom. I'm almost there when the marble falls. Slow. Perfect. There are no critical errors so far. Perfect. This is great news. We're really close to being completely done with the marble gate investigations. I think I only have one video left where I will try to prove that this new gate can handle all parameters like standard deviation, precision, repeatability, and reliability before we can move on to new subjects. But I wanted to share with you an interesting design framework that has helped me immensely during this work with the marble gates. It's a design framework that I think can help you and your projects as well. And it's a design framework that I really lacked during the development of the first two machines. I have failed with not only one marble machine, but actually two marble machines. I think what led me to fail with these first machines was that I underestimated the complexity of these systems. On the first machine, I just underestimated the complexity. On the second machine, I knew it was a really hard task, but I didn't know how to reduce the complexity into smaller, more manageable parts. In this video, I want to tell you about modules and interfaces. This is a design framework that will help me reduce the complexity into smaller, manageable parts and possibly make the whole project doable. Recently, I've been working on marble gate design, and by using the modules and interfaces framework, I've been able to catch a lot of errors that I would have missed if I didn't have this simplified framework. The definition of a module is a distinct subassembly that can be easily added, removed, or replaced in a larger system. And then the definition of an interface is a point where two modules meet and interact. So in this example, the module is the whole marble gate itself. Interface 1 is bracket to structure. Now we can add some data points to each interface to see how this marble gate module need to interact with other modules in the larger marble machine system. So for example, the interface 1 bracket to structure, I've added that there are two M4 bolts, they are 15 millimeters center to center, they need a flat mounting surface, and then they need a clearing distance to the escapement. So later when we design the supporting structure where the marble gate is going to be attached to, we can just import this interface data and the two modules will interact nicely. They will play like best friends, okay? Interface 2 is the marble input from the marble lane. Marbles needs to flow from marble lane to marble gate without hindrance. Interface 3, the open-close connection with the link. For interface 3, we have a whole bunch of data describing every minute detail of how this interface is actually operating. And by actually thinking through every little single action this interface is doing, I think I have foreseen so many errors. Interface 4, it's the marble output to the instrument. We want the marbles to be as close to 0 millisecond standard deviation as possible, and then the target precision, we want the marbles to hit a small hit point. But what I actually want to communicate to you all at home is that if you have a project where you feel kind of lost in complexity like I have been last year's, perhaps the modules and interfaces framework can help you and your project. So again, I have to thank all the engineers watching this channel because I learned about modules and interfaces last spring during the live streams. If I ever get to that world tour premiere live on stage concert with the marble machine, it's going to be a lot thanks to the modules and interfaces framework.